Okay, hello everyone. In this video, we're going to look at the probability of multiple events, like two things or three things happening. Okay? What's the probability that two things happen? All right, there's three kinds of multiple events we're going to look at: dependent events, independent events, and mutually exclusive events. Okay? You might remember these. These are called Venn diagrams. All right? Guys, when the outcome of one event affects the outcome of a second, the two events are called dependent. As an example, the probability of pulling a blue one here is 2 out of 5. But if I pick a red one, now the probability is 2 out of 4 of picking a blue one. But if I pick a blue one, now the probability is 1 out of 4 that I pick a blue one on the second time. So those events are dependent because I'm not replacing it before I pick the second one. All right, when the outcome of one event does not affect the outcome of the second, the two events are called independent. Like if I roll this dice and I spin the spinner, one doesn't affect the other, unless I throw the dice at the spinner or something and hit it. But I'm saying these are two independent events, okay? Guys, there's a formula. If two events are independent, the probability that A and B, that both of them happen, is each of these probabilities multiplied together. All right, if they're independent. So the probability of rolling a 3 is 1/6. The probability of spinning, getting blue on the spinner is 1/4. So the probability of rolling a 3 and spinning blue on the spinner is 4.2%. It's 1/24th, okay? The probability that they both happen is less than the probability of one of them happening, of either one of them happening, okay? The next kind of multiple event is called mutually exclusive. When two events cannot happen at the same time, they're called mutually exclusive. Okay, there's a formula for them. It's a little different. Because here we're talking about either or of them happening. Right? Two events, not both of them happening, because we're saying they're mutually exclusive. Both of them cannot happen. The probability that they both happen is 0. Right? There's no overlapping here. But what's the probability that either or happen? You add up the two probabilities, okay? If they're mutually exclusive. You know, as an example, we cannot roll a 2 and a 3 on the same roll of the dice. Those events are mutually exclusive. So the chance of getting a 2 or a 3 when you roll a dice is 1/6 plus 1/6. All right, that's 2/6. It's 1/3, 33% of getting a 2 or a 3. Now, sometimes events, they're not mutually exclusive. Right? They can both happen at the same time. So if we want to calculate the probability that either one of them happening, all right, we take the probability that one of them happens, plus the probability that the other one happens. But then you have to subtract the probability that they both happen at once. Look at this right side here. See this purple part? When we take the probability that A happens, plus the probability that B happens, we've added this purple part twice. So we have to subtract it back out one time to actually find the true probability that either one of them happen, okay? Oops. Guys, there's another example. What's the probability of rolling an even number and a number less than 3? All right? Let me get this out of the way here. Rolling an even number, of course, is 50%, 0.5. 3 out of 6 ways to get an even number. And a number less than 3, well, there's 2 of them, 1 and 2. So that's 2/6, 1/3, or about 33%, 0.33. The probability that they both happen, a number less than 3 and an even number, multiply those two together. All right, 0.5 times 0.33 is 0.17. So take 0.5, add 0.33, and then subtract 0.17. That's what we do right here. And we get 0.66, which you can recognize as 2/3, or 4 out of 6, which makes sense. What's the probability of getting an even number and a number less than 3? There's 4 ways to do it. So it's 4 out of 6, okay? Let's look at some more examples here. Guys, starting now, this will help you a lot with the exit ticket. We're going to classify this as dependent or independent, this situation. These two events. A month is selected at random, and then a number between 1 and 20 is selected at random. Are those dependent or independent? Well, one doesn't affect the other. They're independent events. All right, if I was saying I'm going to select a month and then I'm going to select a number from that month, that would be dependent. Okay, you're going to need to know that for the exit ticket. Next one, how about a letter from the alphabet I select at random? And then one of the remaining letters is selected at random. You see how I'm not replacing the letter that I selected first. Those are dependent events. All right, one does affect the other because I'm not replacing that first letter. Those are dependent events, okay? Let's look at another example. Guys, Q and R are independent events. Find the probability that they both happen. All right, that they both happen. Again, probability of Q is 1/4. Probability of R is 2/3. Multiply them together. Remember, when you multiply fractions, you just multiply the numerators together, multiply the denominators together, and simplify. You get 17%. Remember, this number is less than either one of these events happening by itself. The probability that they both happen is less than the probability that either one of them happens by themselves. Okay? Next example. Guys, you have a standard deck of cards. Are these events mutually exclusive? I select a diamond or I select a club. Well, yeah, they're mutually exclusive. I cannot select a diamond and a club at the same time. Okay, they're two different suits. No card is a diamond and a club at the same time. I'm only taking one card. Or think of the same deck of cards. Can I select a heart and a queen at the same time? Yes. I could select the Queen of Hearts. So these two events are not mutually exclusive. Okay, learn to recognize that. Just ask yourself, can they happen at the same time? All right, let's say S and T are mutually exclusive events. Find the probability that either one of them happens, one or the other. Just take the two probabilities and add them up. 5/8 plus 1/8, that's 6/8, okay? 75%. Make sure, y'all, when you're adding fractions, you need a common denominator. All right, don't forget that. All right, let's look at something that's not mutually exclusive events, like this bowl of fruit. Here's the bowl down here in the right corner. 2 green apples, 3 red apples, 1 green lime, 2 yellow lemons, and 2 oranges. We want to know the probability of choosing something green or an apple. All right, now we can almost just count them up. There's 5 apples, and there's 1 more green lime. That's 6. And that's what we get, 6 out of 10. Let's use the formula. All right, how many are green? Well, there's 2 apples and 1 lime. That's 3 out of 10 right here. Well, how many are apples? Well, there's 2 green and 3 red. That's 5. And how many are green apples? There's 2. So you have to subtract that out. Because those 2 green apples, we counted them here and we counted them here. So we have to subtract them out once. So that's 6 out of 10, 60%, okay? All right, guys, just do that exit ticket. I'm assuming that you've already done the vocabulary assessment. If you haven't, go ahead and do it. Again, it's in the bottom green folder. You should be in this folder right now watching this video. All right, that's it, y'all. Thank you.